In our next example, we want to come up with an equation for a given graph. And so we want to write our equation in standard form, a cos or sine, depending on which graph we decide we're going to think of it as, b times x minus c plus d. And we need to come up with the values of a, b, c, and d. Now I say in terms of which graph we think of it as, because remember, any sinusoidal graph can be thought of as a sine or a cosine graph. Both of these graphs share the same amplitude, period, and shape. Now the graph I have below here is a sine graph, and we know that because sine begins at the origin point. But remember that a cosine graph is simply a shift of a sine graph pi over 2 units to the left. So a cosine graph starts up from the origin. A sine graph starts at the origin. But a cosine graph is the same as a sine graph that's been shifted pi over 2 to the left. So because of all this, any sinusoidal graph can be written as a sine or a cosine graph. And in our specific example, we're asked to do an equation of each. Alright, so with all this in mind, let's tackle this problem. First thing I can come up with is the amplitude, which I know is the high y minus the low y divided by 2, which is 8 over 2, which is 4. And amplitude is the absolute value of A to be 4, which is saying that A is going to be plus or minus 4 depending upon whether I'm starting with my standard sine or cos or a sine or cos which has been reflected across the x-axis. So we'll come back to making our final determination on A in a bit. The next thing to move on to now is the period. The period is the length of time it takes for the graph to go through one cycle. So if I pick a starting point and I go to the end, there's one cycle. I can see that the period is 2 pi over 3. And I know that B affects the period because B is a stretch horizontally. Could also be a reflection across the y-axis if it's negative. And the connection between B and the period is that your standard period divided by the absolute value of B will be your new period. So we know that the absolute value of B in this case will be 3. So B is plus or minus 3 depending on whether there's a reflection across the y-axis. When you are making up the equation of a sine-cosine function, you can actually always avoid incorporating reflections in the equation by instead using other transformations to account for the graph's behavior. So although I will look at this problem in terms of reflections with and without a reflection in the x-axis, I'm not going to do that with a reflection in the y-axis. And so therefore here I'm going to make B equals 3. I'm going to jump now to the vertical displacement. And remember that on a standard sine and cosine graph, the x-axis is the middle. The vertical displacement is 0. Half the graph is above the x-axis, half the graph is below. So on our given graph, if we look at where the middle is, that would be the halfway point between the minimum and the maximum. So you can add those together. 6 plus negative 2 is 4, divided by 2 is 2. My middle is 2, which is telling me that my vertical displacement is 2 units. In other words, D is 2. So up to this point, we've been able to narrow down our value of D, our value of B, and our A is either plus or minus 4, depending on the graph we choose to use and whether there's a reflection across a horizontal axis or not. The final variable that I need to think about is the C, which is the phase shift, the horizontal translation. And the value of C will depend upon whether I am starting with a sine or a cosine graph. Okay, so we are asked to do it as a sine graph or a cosine graph. So the first thing I'm going to do is identify a piece of the graph that's a regular sine. A sine graph that has not been flipped over the x-axis. So that would be this right here, because that matches my core shape down below. And so with me thinking of it this way, I've now determined that my A value will be 4 because I have not thought of it as going down. Okay, I've thought of it as going up this way. So A is 4. We know that B is 3. We know that D is 2. And now here comes my determination of C. The graph that I've identified has already been shifted horizontally. So if I bring it back to its starting point, its core point, like right here, remember I'm thinking of this as my origin because we've already determined that there's a vertical displacement up 2. Then what I need to do with this standard sine graph is shift it this many units to the right to put it where it is on my given graph. So I'm taking my sine graph and shifting it pi over 6 to the right. So that's making my value of C pi over 6. And so I'm now ready to substitute into my standard form as y equals a sine b x minus c plus d. Now let me just show you another variation for the equation. Let's take this away, and let's suppose that we've identified our sine shape from here. Well, now I'm highlighting what is a negative in front sine graph because it's going down first. It's a reflection in the x-axis. So in that case, my A value would have been -4. My B still would have been 3. My D still would have been 2. But my horizontal shift, again, I've got to put this point at the starting point, which is right there. Okay, because a sine starts at the origin, we would have to move it pi over 6 to the left, which would make B negative pi over 6. So your equation could also have been y equals -4 sine b x minus negative pi over 6, which would be plus pi over 6 plus 2. So I've got two different sine graphs that represent this function. Okay, I was only asked for one, but I've got two. And in fact, there are an infinite number, as you can probably see. All right, now let's do this whole thing as a cosine graph. So again, back to my core picture. I've got my middle identified, and I want to identify a piece of this as a cosine graph, which starts up from the origin. Okay? Or if you flip that across the x-axis, down from the origin. Well, I'm going to identify this piece right here, because that would be a cosine graph that's been reflected across the horizontal axis. And that would therefore mean that my A value is at plus or minus 4. It would be negative because I've decided to start from the bottom and go up, reflected across the x-axis. So in terms of cosine graph, I could have A -4, B3, D2. And the nice part about doing it this way is that there's no horizontal shift needed to get me to where the graph actually is. If I simply think of it as a graph that's been flipped across the horizontal axis, it's matching itself already without a horizontal shift. So C would be 0. And so my equation would be y equals -4 cosine 3 x minus 0. So in other words, just x plus 2. And let's do it one more way. Because instead of thinking of it as a reflected across the x-axis cos graph, you can also think of it as, here's a positive cos graph. It starts up from the origin, and then it follows this traditional pattern. So since I'm thinking of it as starting from the top, my A value would be 4. But I need to put it back to my origin. My origin translated vertically is here. And so if I start with this, I have to shift this graph this far to the right to get me to where I'm at, which is pi over 3. Okay, so my horizontal translation, my phase shift would be pi over 3. My A would have been 4. And my B and my D the same as before, 3 and 2. And so the equation would have been y equals 4 cosine 3 x minus pi over 3 plus 2. So I've come up with 4 different equations, all of which represent the same graph. Just to confirm with the calculator, let's scale my axes the same way I see it scaled in my given diagram. Negative 5 pi over 6 to 5 pi over 6 approximately. My scale, every unit's a pi over 6. And the graph's going between negative 2 and 6, so let's just go a little bit bigger and smaller than that. Maybe negative 4 to 8. And there's all 4 of the equations that I created. And so when I graph, I should get the same graph for all equations. Each equation is a different color, and so you can see the colors overlapping one another. How beautiful is that, if I don't say so myself?